Okay, let me just pull out the slides. Give me a minute. Okay, it's here. Okay, let me pull out the slides first. Okay, and then how was the quiz? Okay, right? I think it's quite fair lah. I didn't twist the question. I think it was correct. I mean, if you do well, it's really our effort lah. Okay, we work together. Right? If you didn't do well, is I'll blame you lah. You didn't study. Okay. Okay, joke aside. Okay, I think it's fair lah. I don't like to twist the question until cannot do one. Okay, everything is fair and reasonable. That is my style. Okay, today we have a lot of concepts, a lot of working, alright, but I have rehearsed this morning. Okay, I could finish everything in 2 hours, right? To come here and talk for 2 hours, I always rehearse 2 hours in my office as well. Alright, so then, okay, so today we are going to start a new deck of slides. Okay, chapter 2, partial derivative and multiple integral. So today I try my best, okay, to finish as much as possible for partial derivative. Alright. Okay, so today this is the learning objective, right? 2-path test. Okay, very important. I always set in exam, right? Calculate partial derivative, also very important, right? Not just for this module, for many other modules, right, later on, because in the real world and in a lot of projects that you are working on, it's always multi-variable, right? It's seldom single variable. Single variable means one dimension, cannot be one, right? In the real world, it's usually multi-variable, right? And then, of course, with any calculus, right, we have to develop the chain rule, all right, for partial derivative. Okay, and then I will go into some geometric meaning and applications. Alright, okay, it's very abstract. I spend a lot of time to explain all this geometric but I think we try our best. Okay. Okay, graph of a 2-variable function. Right, so this is the main difference between the current module, right, and your high school or your poly days, okay, or your math 1. Alright, you were focusing on single variable. Okay, you were focusing on single variable. That's the first diagram. Alright, you are given an input x, okay, or what we call the independent variable. Your output is y, or what we call the dependable variable. Okay, and then the geometry, right? What you will get is a curve, is a graph. Alright, okay, it's a curve. Now, in this module, we are focused with 2 or more variables, but I usually use 2 variables as an example. Okay, the same concept follow, right? 3 variable, 4 variable, n variable. Okay, all these concepts, the same concept follow, right? But this 2 variable function, right? Z, right? We call this Z Z equal to fxy. Okay, so the input now is xy, your independent variable. Your output is the z, the dependable variable, right? Okay, so you have certain xy, all right? Okay, and this xy each will map to a z function, a z number. Fxy give you the z number, right? So with these 3 numbers, okay, you go and plot out this whole thing, right? Okay, and so what you will get is actually a surface, okay, a surface, right? Your x, y, z axis, all right? Okay, where the z number, right, the z, right, is actually make up of the fxy. Okay. All right, this is just another example, right? Surface plot of a function z equal to fxy defined on a domain. All right, your input is your x and y. Your output is your z equal to fxy. right? So this is another example. Okay, this one is a bit a lot of new knowledge. All right, graph of two variable function. All right, graph of two variable function. All right, z equal to fxy. Right, you have 6 minus 3x minus 2y. All right, okay. For those of you who can't immediately identify, all right, this is actually your plane. Okay, this is actually your plane. All right, okay. So it's shown over here. All right, okay. Very easy to get the plane. Okay, this is the defining expression, right? Okay, you sub in. Okay, we always test out easy value. Okay, when we try to plot lah. Okay, we always test out easy value. All right. So you sub in. All right, you sub in x equal to 0, y equal to 0. Okay, so it's 0, 0, 6. You plot. Okay, you plot the coordinate 0, 0, 6. All right. For let's say on the x-axis. All right. Okay, so what you can do is that you can deliberately suck in y equal to 0, z equal to 0. And then you solve, you got x equal to 3. Because all these are sitting on the coordinate, sitting on the x-axis, y-axis, z-axis. So when you are sitting on the x-axis, right, your y and z value must be 0. When you are sitting on the y-axis, okay, your x and z value must be 0. When you are sitting on the z-axis, your x and y must be 0. So that's how you eliminate away and get the other number, other term. Alright? Okay, and then you join up the 3 points. Okay, you can see that it's a plane. Okay, now I don't want you all to go away with this concept that a plane is a triangle or a square or a rectangle. Okay, a plane, okay, is all the way one. Alright? Okay? That means is all the way. All the way. Okay? It's all the way one. Okay? They don't have a endpoint one. It's all the way. Right? But when we draw on a piece of paper, alright, on when we draw it out, we always draw it as a square, triangle, rectangle. It's for convenience sake. Alright? Okay? Alright, so usually it's like this lah. Okay, I'm very bad at drawing now, sorry. Okay. Wow, even worse, right? Okay, anyway, you get it, it's a plane, okay? It's a plane, alright? Imagine this is a piece of plane, okay? It go all the way, it extend all the way, alright? Because I have taught this module until the end of the 13 weeks. Then the student come and tell me, oh, a plane is a triangle, a plane is a square. Oh, okay, they extend infinitely. Okay, they extend infinitely. Okay, you get the idea, and they obey this formula, They obey this formula. Alright, so it can be many different other number expressions. So the plane will be different, will be different adjustment. Okay, alright. So in general, the general expression is like this: z equal to a plus bx plus cy. Right, constant ABC. Right, this is the general plane equation. Okay, and then z equal to square root of 9 minus x squared minus y squared is the upper half of a sphere centered at the origin with radius 3. Alright, that means it's this one. This is the one. Okay. Now I will just do some simple derivation. Right, very simple one. Okay. Okay. Right. So in the above slide, right, we have z equal to square root of 9 minus x squared minus y squared. Okay, we can actually square both sides. Okay, so if you square both sides, you have z squared equal to 9 minus x squared minus y squared. Alright? And then you will get x, you rearrange them nicely, x squared plus y squared plus z squared equal to 9, which is 3 squared. Okay? So this is, okay, we learned in high school, right? Your x squared plus y squared equal to 3 squared, right? Is your circle, right? Radius 3, right? But now, because we have one more, okay, one more variable, right? This is actually a sphere, okay, a sphere of radius 3. Okay, it's a sphere of radius 3. Alright? Okay? Now, but the question given to you, right? The question given to you is the square root lah. But before we tackle the square root, okay, so from here, right, if those of you who can't relate to what you learned in high school, the equation, the expression for a circle, right, you can very simply do this. Alright? You sub in x0, y0, okay, sub in y0, z0, x0, z0. Alright? So basically, you go and sub in all the points, okay, you'll get all this, okay, all this point. Alright? Okay? You get all this point. Right? You will be able to see the relationship. Right? But in general, we try to relate this back to what we learned in high school. The expression for a circle. Right? Okay. Now, the part here that I want to mention is that from here, okay, from here, you must take note that what you are given is actually square root. Okay? So if you square root x squared plus y squared plus z squared, that will give you 3. Alright? This one. Okay, sorry. That will actually give you this one. Alright? Because with the virtue of the square root, it dictates that everything must be positive. Your y value must be positive. Okay, your outcome must be a positive. Right? Which means that it's actually a upper half of a sphere centered at the origin with radius 3. Okay? Right? Just a small subtle difference, right? Okay? If I give you this, if I given you this, it's definitely a sphere. But if I given you the square root version, right, it now become a upper half of a sphere. Okay? Upper half of a sphere of radius 3. Hemisphere lah, hemisphere. Okay? Another name for him, hemisphere. Okay? Right? Okay. I also went through many different multivariable function, some shapes and all that last year. Okay, so I thought I will just mention them again. All right, in case your other modules require, at least you have seen all this before. Right, so sphere of radius r, okay, centered right at x naught, y naught, z naught, right? Because your center can be anywhere other than an origin. Alright? So that will give me the expression x minus x naught square plus y minus y naught square plus z minus z naught square equal to r square. Okay? Okay, now if you want to try to describe a solid ball, okay, you want to try to describe a solid ball, so you have x minus x naught square plus y minus y naught square plus z minus z naught square. Okay, we write it this way. Okay, less than or equal to r square. Right, that means it's solid, everything inside. That is to represent everything inside. The equal to r square is just the surface only, describing the surface. Right, less than or equal to r squared, you are describing everything inside. So it's a solid ball. Okay, it's a solid ball. Alright, and number 3 is the ellipsoidal, alright, ellipsoidal x minus x naught squared over a squared plus y minus y naught squared over b squared plus z minus z naught over squared over c squared less than or equal to 1. Okay, this is the ellipsoidal. Okay, alright. Let me just give me a minute. Let me generate the figure for you. Alright, I think you may not heard of ellipsoidal. Can you meet that? We always normalize it to 1. Yeah, then we put it all at the ABC below. There's reason. Okay, let me show you a nice figure. Let me show you. Okay, I randomly choose this lah. Let's hope. How come now every time is the advertisement on? Okay, how do I skip the advertisement? How come this YouTube? Okay.
An equation of this form would give us a surface looking like this. So let's start by putting the 0 into the z. So when you put 0 into the z, you could imagine a horizontal sheet of paper where the height is so imagine this is your z-axis, and imagine this as being -1, the horizontal circle or an ellipse depending on your constants a and b. Given this equation here, if you put 0 into here, then in your mind picture a horizontal sheet.
Okay, I think this is a bit messy for the video. Okay, yes. Okay, give me a minute. Let me find another one for you. I actually found just now before I came. I remember I went to search for this. Give me a minute. Let me pull out the picture. Okay. Wait, I'm searching for my photo album. Okay, yep. Okay, I found one very beautiful one. Together with many other shapes that I want to share with you. Okay, hold on. I'm trying to load the. Okay, this is the one. This is the one that I want to show you. Okay, sorry about this. Okay, come. Yeah, this is the diagram I wanted to show you. I think this is the best I could find, right? So you show you all the diagram over here, right? So ellipsoidal is here, alright? So the ABC is to show you the extent of how much is being pulled, right? So this is the cone formula, right? Elliptic paraboloid, okay? Hyperboloid of one sheet, okay? Alright? Hyperbolic, paraboloid, and hyperboloid of two sheets, okay? So they use all these shapes, okay? They use all these functions to design those aesthetic building, right? That you see very beautiful one. And also for nuclear plant, chemical plant, right? There is certain reasons, alright, why they need to make the shape like this, okay? I'm not a chemist, I'm not a material, but they have this kind of shape, okay, is for certain purpose, okay? You can easily read it, right? Usually you will see the nuclear plant, chemical plant, they will use this shape, hyperboloid. Okay, alright. So these are the generic formula for them, okay. I don't think I would test you all on all this, okay. Even if I test you, maybe I'll give you the expression, alright, or I will give you. I mean, yeah, I wouldn't. This one is, yeah. Usually I don't give the shape, because I give the expression can already. You can handle it can already, right? Don't need to go into the shape to do the analysis. Okay, good. Okay, so yeah, now let's move on. Okay, now let's move on. So these are just to show you some computer generated for this kind of multivariable plots, usually it's software, I don't expect you all to go and draw it on your own, okay? I think it's too tough. When I was a student, right, they really forced us to draw this kind of thing. I'm not joking, because there are some special point that you will identify immediately, so you can anchor those special point, and then you don't draw it wholesale, right? You slice it. You look from one plane, right? Because it's X, Y, Z. If you look from one plane, you kill off one plane. You look from a side view, you kill off one plane, right? That means what you are seeing, another you are seeing is the 2D version that what we have been learning in high school, right? But of course we have to modify the expression. So then we form up the shape. Okay, all this we really draw by hand one. Okay, maybe it's a good time to test you. Okay. Anyway, no lah. I'm not. I focus more on concept that I think is important that will take you off for life. Okay, you have all these fundamentals. Okay, some baseline, some fundamental. That is the main purpose okay, for my philosophy. I want to give you a strong foundation and some baseline, right? Okay. Now this is our lesson proper already. Limits of multivariable function. This is our lesson proper already. So in Math 1, they focus on limits of single variable function, right? So now we focus on multivariable function. Now this page, this page is more for motivation. Okay, it's a motivation, right? This method is unacceptable in the exam or quiz. All right, but it's more about motivation, right? Exciting, right? Okay. So if I tell you I have two functions, f is very complicated, right? Sine x squared plus y squared over x squared plus y squared. Okay, g equal to okay, right? So now I ask you, what is the limit of f as x, y approaches 0, comma 0, right? This is the traditional method, maybe 5,000 years ago, right? Where they have not developed the technique yet. Okay, what you do is that you subpoint, all right, and see what is the value around 0, 0. So you look at 0.1, 0.1, you look at negative 0.1, negative 0.1, you look at 0.005, 0.005. You look at all the points that are around, okay, that is limiting, right? Okay, it's limiting, right? See, you look at all these points, right? So this is 0, 0, what you're interested in, all right? But obviously, you sub in, you cannot get any answer, right? Sine 0 over 0. Okay, sine 0 is 0, 0 over 0, right? Okay, I said many times already. Okay, whoever give me this in the exam, cancel 1 Okay, I give you. I don't know. And to make you recourse again, I don't make you come back another time. Okay, so here is cannot nothing. We can only find out the limit. Alright. So for this case, you can see that when we are approaching 0, 0, okay, from here, approaching 0, 0 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 from here, approaching 0, 0, is all converging to 1. It's all limiting to 1. Okay, that we say. Okay, limit of xy approach 0, 0 if you want. Now, for this other guy, the g function, okay, you can see very clearly when you're approaching 0, 0 is 1. You're approaching 0, 0 from here is negative 1. Game over already. Okay, right? You're talking about limits in the single variable world, right? The left limit and right limit must be the same for you to give the limit and answer, right? The left limit and the right limit must be the same. Now you're in the multivariable calculus world, all right? So at a point that you're looking at 0, 0, for example, right? It's not just left limit, or there's no such thing as the left limit or the right limit. It's look at all the possible paths, right? Let's say this guy is the 0, 0. You have to look at all the paths leading towards him from here, all right? Can be from here, can be from the back, okay? Can be from here, can be from coming in here. Because it's a multivariable calculus world, right? So to prove that it's 1, right? Of course, you need some sophisticated method, but to prove that it does not exist, okay? To prove that it does not exist, right? You can just, find 2 paths where it give you 2 different limits. 2 paths leading to the 0, 0 that give you different limits. Alright? So here is negative 1 straight away, no need to talk already lah. The limit does not exist. Okay? Okay, I will skip this part here. Okay? Right? Limit of a single variable function. Alright? Okay? This is what we call the epsilon delta definition. This is the original invention of limits. Okay, this usually taught in a maths course for 1 hour to 2 hours, just on the epsilon delta. Okay, I will skip because I'm not going to test you epsilon delta, right? So I will skip it, but I include that in case you have some memory of it. All right, but even if you don't have, I won't fault you. All right, you won't be penalized. Okay, so epsilon delta is always about playing a game, right? Okay, you have this condition, right? And then, okay, you have this condition, then you can state the limits. Okay, it's always, you have to look at here and here, alright? Okay, so that's the original epsilon delta. Okay, I don't want to go too deep into it. Now, limit of a 2 variable function, this is an extension of the previous epsilon delta concept, alright? Okay, so I will just briefly mention, alright? Let fxy be a 2 variable function defined in D, right? D is the domain, alright, which include points arbitrarily close to AB. AB is what you are interested in, right? We say that the limit of fxy at AB is L, and we write it this way. Okay, we write it this way. Okay, And this means that for every small number, positive small number, epsilon greater than 0, there is a corresponding, you can always find a delta greater than 0 such that it obey this formula, these two formulas. Okay, alright. Okay, I will not go through this. Right, this one usually we teach 2 hours just to go through this epsilon delta for the mathematics major. Alright, okay, don't worry, okay, you won't get to use this. Right, okay. So it's always about finding a small epsilon. Okay, it's always finding a small epsilon, right? And at the same time, you are in the neighborhood. Okay, you are bounded by a delta. Okay, come back to here. Okay, the delta, and that's the meaning of limits. Okay, you must be able to find that. Once you're able to find that, then you can state the limit. What is the limit? What's the number? Okay, let's move on. Okay. Don't worry, alright? Okay? All this very, very complicated that you have just seen, alright? Okay? Over the years, people have developed, okay, some theorems, alright, from those complicated things that I've just shown you. Alright? So, this is an important slide. Alright, that you must, I hope it's intuitive to you. Okay? You don't have to force yourself to memorize all, but you need to remember them. Okay, you need to apply to solve limits question. Alright, so right, so the following hold if L, M, K are real number. Alright, so assuming you are given this condition, this limit x, y approach x naught, y naught, f x, y equal to L, and number 2 is, okay, limit of G, x, y approach x naught, y naught equal to M. Alright, okay, so let me just briefly go through, right? So if you limit x, y approach x naught, y naught, okay, your f plus g basically is your L plus M, right? Okay, all this limit must write, okay? I will not mention it, okay? Very powerful limit, this, okay? So this is fxy minus g, so it's L minus M. Okay, you have a k in front, KL. Alright, you have a f function times g, LM. F function divided by g, L divided by M, provided M not equal to 0, of course. You have this limit of f holding power n, just L n. Square root n of f, that will be square root n of L. Okay? Alright? Quite intuitive, right? Okay. Now let's move on. Okay, now let's move on to this warm-up question. Alright, find the limits. Okay, find the limits. Now, this is the quick and dirty rule. If your fxy is continuous at AB, right, you can just sub in the limits. Okay, you can just sub in the limits, right? X equal to A, y equal to B, right? And it can give you an answer. That answer is the functional value, right? Okay. Okay. So for the first question, right, very beautifully, I sub in x equal to 1, y equal to negative 2. Okay, I sub in the expression. Okay, I will solve and I get square root 5. Full stop. Okay. Next, okay, I have limit of xy approach 0, 0. Okay, x squared minus xy over square root x minus square root y. If you try to sub in, okay, you get 0 divided by 0. Okay, you get 0 divided by 0. Alright? So, it means that this expression, is not convenient for us to work with. Okay? You must try to use your high school method. Right? Sec 3, Sec 4, right? During Sec 3, Sec 4, you will have learned this thing called surds, rationalizing of surds. Alright, I hope you can still remember all this. Okay, I started off as a high school teacher, so I have taught all the way from Sec 1 to Sec 4 to JC 1 to JC 2 before I went to do my PhD and then join university. So every year in my class, there will be a student from my previous teaching time. That means it could be like Sec 1, then now in NTU, or could be like Sec 3 student now in NTU. But I think now don't have already. I think I'm too old already. Yeah, because they will have all graduated already. Yeah. Okay, anyway. Yeah, every year will have, no? Very interesting. Every year, no? What is the chance? Right? There are so many. There are maybe 100-degree courses. Okay. So anyway, coming back to here, right? The x squared minus xy. Okay, you go and simplify it first. So you become x bracket x minus y. Okay. The bottom is square root x minus square root y. Okay. You go and rationalize it. All right. So I will multiply by square root x plus square root y over square root x plus square root y. This one cancel off is times. You are multiplying by 1. So there's no change to the question. But you are able to change the expression. You are able to give another equivalent. Right? So the bottom is very straightforward. This is a minus b times a plus b. So it's a squared minus b squared. So a squared minus b squared, you get x minus y bottom. Alright, and the top here is x minus y, and square root x plus square root y. So cancel, you have x times square root x plus square root y. You submit x equal to 0, y equal to 0. Now you can sub it in and properly evaluate it, and the answer gives you 0. Okay? Okay, now we move on to the next question. Use a suitable substitution to convert the limits, okay, into limits of single variable function and calculate the limits. Okay, so again, it's some complicated question, right? So if you can try to make them look more friendly, that for you to handle it, that would be great. All right. So how do we proceed? The first one, we will let u equal to x squared plus y squared. All right. And then xy, the meaning of xy approach 0, 0 means u approach 0. Because x 0, y 0. So u equal to x squared plus y squared. So u is 0. Okay? Why I do this? Because I see this very annoying. Okay? I saw, right? X squared plus y squared. So I let it be u lah. Okay? But I try lah. We try. Okay? We try. Alright? It may not work. Okay? We try. We don't know. Alright? So in this case, when you let u equal to x squared plus y squared, right? Your xy approach 0. Your xy approach 0, 0. Alright? 0, 0. Alright? That implies your u approach 0. Alright? So when you do the limits, okay, always write down the question first. Alright? And then the xy approach 0, 0 become u approach 0. Right? The sine x squared plus y squared becomes sine u. The x squared plus y squared become u. Alright? Okay? And then now you sub in the 0, divide by the 0. You have 0 divided by 0. 0 divided by 0, you can use L'Hopital rule. Remember L'Hopital rule? Okay? L'Hopital rule. Alright? L'Hopital rule means that if you have 0 over 0, okay, you can continue with limit u approach 0. You differentiate the top, differentiate the bottom. Okay, so I differentiate the sine u, I differentiate the u. So I differentiate sine u, I get cosine u. I differentiate the u, I get 1. Now, then I try to sub in the 0 again. Cosine 0 divided by 1, I get 1 divided by 1. So answer is 1. Okay, L'Hopital rule. Okay, L'Hopital rule is for 0 over 0. Okay, make a mark. Okay, if you forgot about L'Hopital rule, I've never heard of it, make a mark. Okay, just go and do a quick search online. Okay? It's a very straightforward, right? You have 0 over 0. Just use L'Hopital rule. Alright? Okay, next one. Okay, next one. We have 1 minus cosine xy over x squared plus y squared. So this time round, okay, the I saw is u equal to xy. Okay? Alright? So, xy approach 0, 0. That will give me u approach 0 lah. Right? Okay? Alright? Okay, and then we try to see whether we can work out something or not. Okay, here. Let u equal to xy. Alright, so you have limit, okay, you change the limit to u approach 0, 1 minus cosine u over u squared. Okay, and at this stage, okay, at this stage here, you try to sub in the u equal to 0. You get 1 minus cosine 0, which is 0, u squared, which is also 0. Again, you have 0 divided by 0. 0 divided by 0, always try to use L'Hopital rule because it's the faster and most efficient way. Alright? Okay, so you differentiate the top, the numerator, and then you differentiate the denominator. Alright? So you differentiate 1 minus cosine u, you will get the negative is outside already. Okay, and differentiate the cosine u, you get negative sine u. And the bottom u squared, you differentiate, you get 2u. Alright? And then you sub in u equal to 0 again. You sub in u equal to 0 again. Alamak. Okay, you get sine 0 over 2 times 0. That means it's still 0 over 0. It's okay. L'Hopital rule again. Alright? Okay? L'Hopital rule. Okay? So, negative is positive lah. Differentiate sine u, you get cosine u. Differentiate 2u, you get 2. Now you try to sub in u equal to 0 again, you get 1 over 2. Alright? Okay? It's very powerful, right? L'Hopital rule, because he differentiate. So whatever you have complicated one, after he differentiate, it becomes something simple. Right? So you see like the 2u just now. Now it become differentiate become 2. Okay? It's L'Hopital rule, he's a French. Don't call him hospital. I don't know, exam student will write there hospital by the hospital rule. Okay? It's L'Hopital. He's a French, okay? He's a French. Alright? Okay, now let's move on. So this is the one that I was mentioning just now, the two-path test for non-existence of a limit. Right? Now, we are in the multivariable calculus world. Okay? There are many paths leading to the x approach 0, y approach 0. Alright? Okay? Infinitely many paths to approach a generic A, comma B. Existence of a limit means all paths has the same limit value. In the single variable calculus, right, limits exist when the left limit equal to the right limit. Right? That is the limit. That's the number. Right? Now, it's not just left limit, right limit. Now it's all paths. Right? You can see so many paths leading towards AB. Right? So the theorem here, two-path test for non-existence of a limit. If a function fxy has different limits along two different paths as xy approach AB, then we say that this does not exist. Okay? Right? A theorem is a theorem lah. We see an example more concrete. Okay? Wow, I prepared many examples here. Okay, overly. Okay, I believe you can see it lah. I usually set this one. I will usually set a question in the quiz and exam lah. Usually everything will come out lah. Okay, your exam is 2 hours 2 hours 7 questions. Right, so everything that I thought will appear one Okay, there's no need to like. Okay, you also don't waste time. Right, you don't have to guess what chapter will come out, what topic will come out. Everything will come out. Okay, all right. Okay, there's 2 hours. There's sufficient time to test everything. Okay, anyway, this is a ugly looking function. Right, limit x approach 0, y approach 0. X squared minus y squared over x squared plus y squared. I give you the hint, right? Show that it does not exist. Okay? Now, you must find 2 different paths that give you different limits. Then you can conclude that the limit does not exist. Usually when we start this kind of question, okay, you must have an intuition. The limit is equal to a number or the limit does not exist. You must have take a side. Okay? You must take a side. Right, and then you try to work towards that through some guess and check. Alright, okay. In the quiz and exam, I will not be so nice to tell you, show that it does not exist. I will give you the expression. Does the limit exist or does not the limit not exist? Okay, alright. Okay, I'll let you know first. Okay, so usually, generally, what do? we always analyze the x-axis and the y-axis. Okay, you consider the x-axis moving towards 0, 0, okay, x-axis, and also along the y-axis. Of course, the way you choose the two different paths depend on what is your this number. All right. Okay, it depends on what is your this number. Okay, since x approach 0, y approach 0. All right. Okay, you can try x-axis and y-axis. So the first one, okay, first step, always write down the f function, original question. Along the x-axis, x-axis means your y is equal to 0. Your x is running. Okay, x can be any value, alright? But your y equal to 0, okay, along the x-axis. Right, so fxy, okay, the x you don't know what number he is. Right, so you leave it as generic one. You leave it as generic. The y is equal to 0 on the x-axis. So it's 0, 0. So your x squared divided by x squared equal to 1. For all x not equal to 0. Alright? Okay, because 0, 0 cannot be touched. Right, so you exclude away the 0. Alright? Along the y-axis means x is 0. The y is running. Okay, y is, any value along the y-axis. Right? So you keep the y, okay, you change the x to 0, you get negative y squared over y squared. You get negative 1 for all y not equal to 0. Again, we know that 0, 0, the function is undefined, so we cannot touch the 0, 0. Right? So we make this kind of remarks. Right? So straight away, you have two paths leading to 0, 0, where they give you two different limits. Right? So you can conclude that it does not exist. Okay, you can conclude that it does not exist. Okay, all right. Okay, so this is the working. All right, if you write out algebraically, this is how it looks like. All right. Okay. Okay, next question. All right. Okay, right, so this is the one. Okay, now, next question. Show that, okay, limit of x approach y 0, 0, xy over x squared plus y squared does not exist. Okay, show that. Now, so, of course, you won't have the luxury of the figure lah. I won't give the figure to you in the exam, okay, right? But you can see from here, right? 0, 0 should be here lah. So you try to, you can see that 0, 0. There is, when you are nearing it, the functional value has two, right? One is this thing is lower, one is a higher at 0, 0. So if you have the graph, of course, okay, you can have a good sensing lah. Okay, but okay. You can also do trial and error. Alright? Trial and error. Okay? So, in this question, right, the intuition is that you have to try the x-axis, y-axis, and another line. Okay? So, let me demonstrate to you now. For this type of question, I would say that there's a lot of guess and check involved. But usually, you start out with the x-axis and the y-axis. Okay? Okay, so for this question, all right, you can see that this question rests, okay, if y equal to 0, right, if your y equal to 0, okay, y equal to 0 means your x-axis lah, means your x-axis, okay. Now, if y equal to 0, you sub in y equal to 0 into your question here. You sub in y equal to 0. So you have 0 divided by x squared. And that gives you 0. Okay? So the conclusion is that your fxy approach 0 as xy approach 0 along the x-axis. This is your first path. Now, second, I told you already, Alright, you try another path. Okay. So usually we take you have tried x-axis already. Now we try the y-axis. Right? So for y-axis, x equal to 0. That is his definition. Alright? So when x equal to 0, again, you sub back to the original f function, x equal to 0. So you have 0 divided by y square. So you have 0. Okay, you write in this way, 0 divided by y square, you get 0. So you conclude that f approach 0 as xy approach 0, 0 along the y-axis. So this is your second path. Now, many students will then conclude that the answer is 0. Just because of two paths that give the same answer. Okay, I will also give you 0. Okay, multivariable calculus, you cannot try two paths, right? You try 1,000 paths, I will still minus mark. Okay, you try 1 million paths, okay, I respect you, but I will still minus mark. Okay, because it's infinitely many, right? 1 million is not enough, infinitely many. All right, okay, and this question, actually, you should have some sensing, get some sensing. Okay, that is a little bit, not so straightforward one, right? So although we have obtained identical limits along the axis, that does not show that the given limit is 0. No. Okay, let now approach 0, 0 along another line. Let's say y equal to x. Okay, y equal to x. Okay, so y equal to x. For all x not equal to 0, alright? So now you change all the y equal to x, and for all x not equal to 0. Okay, so we go back to the original expression here, right? You change all the y equal to x. So that's why you will have x squared over x squared plus x squared, and you get the answer half. Okay, then you can conclude that f approach half as xy approach 0, 0 along the line y equal to x. Y equal to x is still a valid path because 0, 0, the y equal to x line passes through 0, 0. Alright, so you going back here. Okay, sorry, just now I mentioned you look at the y-axis, x-axis, and also look at the y equal to x. Okay, I see wrongly. I said look at y equal to half. Okay, sorry, obviously wrong. Okay, you look at the x-axis, y-axis, and the line y equal to x. So these are the three most important axes that you should always try for. Okay, y-axis, x-axis, and the y equal to x. Usually, if things happen, these three will tell you. Usually, not all the time, right? Depending on the question, you must be innovative enough to deduce carefully. Alright? And then after this, okay, then you are now in the position to say that since we have obtained different limits along different paths, the given limit does not exist. Okay, next question. Okay. Does the limit below exist? This is the type of question I will ask in the quiz. I will not tell you it exists or does not exist. I ask you, exist or not? Okay? This is the type of question. Okay? Okay, for this question, right? With the previous idea in mind, we will save time by letting xy approach 0 along any line through the origin. Wow, now more powerful already. No longer just x-axis, y-axis, and y equal to x. Okay, we are more ambitious now. Okay, we want to assess, alright, y equal to mx. So if the line is not the y-axis, then y equal to mx, okay, where m is the slope. Okay, so line equal to y equal to mx. Okay, so your x can be 1, your x can be 0, your x can be 2, x can be 3, x can be 4. Alright, so you replace, okay, you replace all the y by mx. Alright, replace all the y by mx. Right, then that will give, okay, you sub inside here, you look back at here, sub the y equal to mx. Alright, okay, then you simplify, okay, you get up to here. Alright, because now it's all x already. Okay, now it's all x already. Alright. Okay. So your f approach 0 as xy approach 0, 0 along y equal to mx. We get the same result as xy approach 0, 0 along the line x equal to 0. Thus, f has the same limiting function along every line through the origin. But again, that does not show that the given limit is 0. Alright? Because this question, right, you see that there is some square lah, huh? You see that there's some, it's not straightforward. Okay? So in this question, we deliberately let x equal to y square. We analyze, instead of a line, okay, we analyze a parabola. It's also okay. Right? The path need not be a line. Okay, it can be a parabola. So let's say I analyze x equal to y square. Okay, I replace all the x by y square. Alright, I change the formula. Okay, and then here I can simplify it easily. Cancel, cancel, I get half. So you conclude that f approach half as xy approach 0, 0 along x equal to y squared. Again, different paths lead to different limiting values. The given limit does not exist. Correct? The given limit does not exist. Okay? Alright? I think this is the toughest toughest question, right, in this segment. Alright, in this segment. Alright? Okay. Okay, now let's move on. Okay, now let's move on. Right? I will give you a 5 minutes break, then you come back. Okay? Today lesson I took 2.5 hours, right? Last year. Right? So okay, today I think we are doing well for now. Okay, you go for a 5 minutes break, alright, then come back. I will start the class exactly at 5 minutes. Okay, I will start the class exactly at, I'll start the class exactly at 5 minutes. Okay, let me switch on the timer now. Yeah, let me switch on the timer now. Okay, I have labeled the timer. Go for a break, go for a break, go for a break. Yeah.
Does the line analyzing need to lie on the surface?
The what?
Does the line analyzing need to like exist on the surface?
I didn't pass through the point. You must be inside the movie. You must be inside the movie. You can actually pass it on.
Because for example, there's like, for example, you can have a load of forces like that.
Actually, it's all the line across. As long as they contain the 0, then you can pass through the 0, 0.
Okay, but it doesn't need to be the weight of the surface thing. So as long as I choose a line where I can substitute x equals 0 and y equals 0, correct? I can substitute every correct.
Because it's actually, you're only interested in the limits near there.
Okay.
Yeah. So you can use any line as long as it's containing that one. Yep. Okay, go for your break. Okay, guys, go for your break. Go for your break. Okay, sure. Okay, sure. I may use all the way. Okay, I will try to, try to press it. Give me some time. Oh yeah, there's also the makeup quiz. Those of you who need to do the makeup quiz. Okay. Yeah. I have it at the neighbor LP. Okay. Time is up now. Alright. So we have gone through all this, right? So the idea is really, right, always try x equal to 0, y equal to 0, y equal to x, alright? And for some more complicated case like this, right, you have to go and analyze until x equal to y square. Okay, x equal to y square. Right? Okay, is any path, because it's a multivariable world, right? So it's any path, right, in the world, in the 3D, in the whole world, all right, as long as it's contain the 0, 0. Because what you're interested in is, limiting to 0, 0, right? You're not concerned about far away from 0, 0, all right? Okay, now let's move on, all right? This is another main dish for today, partial derivative, right, definition and rules. Right, it's very, very important. I cannot emphasize this enough, all right? Basically, your high school calculus, right, or when you learn in your diploma days, right, your calculus rules and all that, right, and also in Math 1, etc., it's all for single variable calculus, right? The rate of change, they call it the rate of change, they call it the slope, they call it the derivative, right? There is an equivalent here in multivariable calculus, there is an equivalent, right? And the equivalent is called partial derivative, right? So this partial derivative is the equivalent of slope, gradient, you know, but it's not called slope, it's not called gradient, it's called partial derivative, okay? Right? So just like ordinary derivative of one variable function, partial derivative are still interpreted as slope, right? But there are multiple ways to cut through the mountain to define the slope, right? Because now you're not looking at a 2D curve, you're looking at a mountain. All your shapes are like mountain. Okay, I think that's the easiest example for you to visualize. Every shape you're looking at is a mountain, right? And then, so at mountain, you want to look at the slope, right? Before you find the slope, you need to cut the mountain first. Cut the mountain already, then you have a curve, then you find the slope of that curve. Okay? The slope of fxy on the surface at xy depend on which direction you move off in. Alright? The obvious direction are those, the x-axis and y-axis. Alright? Okay? So this is the upgrade version, alright? From single variable to two variable function. Okay? Now we no longer say df dx or df dy. Okay? Now that you see the symbol in front, right? We call him del f del x. Okay? Del f del x. Okay? Del f del x is the short form. Alright? It's actually the partial derivative of f xy with respect to x. Okay? Because your bottom is x. Okay? Your bottom is x. So with respect to x. So when you do that, you treat the y as a constant. Okay? Alright? And the formula is as follows. This is what we call the first principle. Okay? Limit of h approach 0, f. Now your x, you give it a small change. Right? So you plus h, comma y is kept as constant. Y is kept as constant. Minus fxy divided by h. When limit h approach 0. So this is this should be the focus of your math 1, right? I mean, or back then. Okay. Now another one is the del f del y, which means it's the partial derivative of f xy with respect to y. And when you differentiate with respect to y, you keep x constant. Okay? Right? So you have f, x. Now you have a y plus h. Okay? The y, you need to give it a small change. Alright? Minus of fxy divided by h when limit h approach 0. Right? Your x is now a constant. Okay? Different textbook use different notation. Okay? They all mean the same. Right? Del f, del x. Sometimes they write f small x here. Or they write this symbol. Okay? Del f, del y. Okay? Right? But you cannot write this. This has no meaning. This is what you use in single variable calculus. But this has no meaning here in multivariable calculus world. Because you need to tell me, you are looking at so many different variables. Which variable are you interested in? Alright? Which variable are you interested in? Okay? Right? Partial, partial. Okay? Partial. Right? So you need to let me know which one you are looking at. Okay? Let's take a look at one example. Okay? Let's look at one example. Right? If fxy equal to sine of x over 1 plus y, find del f del x and del f del y. Alright? Okay, so I have the model solution in the slides already. Alright? Okay, I prefer my own handwriting. Okay, so now, for this question, sorry. Now, for this question, right? Okay, you have to look at it this way. Alright? Sine, I put a bracket here, nicer. Okay? Right? So you del f del x. So you must in your mind, okay, del f del x means I differentiate with respect to x. Alright? But the y that I see, I should treat him like a constant, just like a number. Okay? Right? So I do a del f del x, right? Differentiate sine, I will get cosine x over 1 plus y. Okay? Right? I directly differentiate. Okay? With respect to x. And now, remember, okay, your chain rule from your calculus 1. Okay? After I differentiate the sine to become cosine, I cover the cosine. Okay? And I differentiate the inside here. Okay? Which is what I wrote here lah. Okay? Now, don't tell me you cannot differentiate x over 1 plus y. Okay? Right, this guy, okay, you differentiate. Okay, x 1 plus y negative 1. You should put the del, you should put the del symbol, okay, because got x and y involved. Alright, so I'm executing chain rule. So differentiate respect to x, okay, you are treating the 1 plus y inverse as a number. So when you do that, he will just follow as well. Okay, the x you differentiate, it become 1. So I will have this term here. Okay, is that clear? Alright, is that clear? Okay, so this part here, I copy it down here. Okay, you have to do this because of chain rule. Okay, and this I got here. 1 over 1 plus y. Okay, this is chain rule. I just write here in case you all forget. Now, del f del y, okay, del f del y, okay, your differentiating respect to y, x as a constant. Okay, so again, del f del y, you differentiate sine x over 1 plus y, there's y inside lah, right? So you differentiate, you get cosine x over 1 plus y. And then chain rule, you cover the trigo, okay, you differentiate the inside, okay, but now you are differentiating respect to y, so you del y, x over 1 plus y. Okay, so what is this? Okay, again, I do for you. This part here, right, is your chain rule. So del y of x 1 plus y inverse. Okay, your x is a constant, is a number. So I just write him down, x. Okay, and then your 1 plus y powers negative 1. It's just like product rule. So negative 1, 1 plus y minus 2. So you get negative x over 1 plus y power 2. Okay, so this part here give you this negative x over 1 plus y square. Okay, and the first term that you already done, remember to put it back here. Okay, chain. Okay, okay, all right. Okay, let's move on to the next question. All right, del f del x for the function below. All right, so this one straight away, right, you have to think of product rule. Okay, you have to think of product rule. All right, you have to think of product rule. All right, there are two terms here. So I do del f del x. Del f del x means that you are differentiating respect to x. Okay, you keep the y as a constant. Okay, you keep the y as a constant. Right, so this is what I will do. I will product rule, right? There are two terms. Copy down the first term, differentiate the second term. Copy down the second term, differentiate the first term. So x squared become 2x. Okay? Right? And after that, x squared copy down, differentiate sine xy. Okay? I will get sine will become cosine xy. Right? After that, you cover. Okay? After that, you cover the function. Right? After that, you cover the function. Differentiate inside. Okay? Differentiate inside. Because now you are differentiating with respect to x. Okay? So your y is a constant, is a number. Take out the y. So you have a y here. Alright? Okay? Likewise for here, just simplify. Okay? Always leave it to the most simplified version. Right? Okay? Always leave it to the most simplified version. Okay? That's all. Right? Up to here. And the next one, del f del y. Okay? Del f del y. So now you are differentiating respect to y by keeping x constant. Okay? So again, the same thing. I copy down the x squared. I differentiate this respect to y. So sine xy become cosine xy. Cover the trigo function. Differentiate the xy inside. Okay. Now your x is a constant. Right? Cosine xy. Your x is a constant. Did I make a mistake here? Let me see. Wait, let me just. I take down x squared, right? And then I differentiate sine xy, I get cosine xy. Right? Then I cover the trigo, I differentiate xy, I get x. Correct. Correct. Okay, correct. Okay? Correct. This is correct. Right? Because you differentiate respect to y. Right? So you differentiate the xy, differentiate the y, right? You're left with the x only. So you put another x here. So it's x squared x. Okay? Then you simplify it. Okay? You get x cubed cosine xy. Alright? The other term you know that is 0, right? Okay? Because if you do by product rule, right? Okay? You put down sine x, you put down sine xy. Right? You put down the sine xy. Okay? But you differentiate x squared with respect to y. Right? So you get 0. Right? So this term is 0. Okay? That's why there's only one term here. Okay? The other term goes to 0 when you do the product rule. Okay. So the important point, okay, guys, the important points to note here is really the chain rule. Okay? I cannot emphasize that more. Okay, it's really the chain rule. Alright, so make sure you execute the chain rule carefully. Alright, like this one. Okay, after I differentiate the f, right, from sine I become cosine. Right, this one, let me do it again. Okay, I should emphasize this. Okay, del f del x. Okay, from the sine become the cosine. Okay, then whatever you have here, copy down. After that, you cover the trigo function, you differentiate inside. This part here. Okay? That is the whole idea. Chain rule. Okay? This is from a single variable calculus. Alright? Okay? Likewise from here. Okay? After you differentiate, sine become cosine. Right? You cover the trigo function, you cover the first function. Right? You differentiate the inside. Okay? Okay, good. Right, so this is the same question, right? This is the same question which I've already gone through. Now you are comfortable with the calculation, all right? So I can also show you the generic idea. In single variable calculus, it's easy to show. I can easily draw a graph and show you the slope, okay, and everything else. Draw it nicely for you. In multivariable calculus world, it's very abstract. Okay, I just do a simple illustration for del f del x. Okay, del f del x. All right, del f del x. Now, If I tell you I want you to find del f del x at a comma b, a point a comma b, okay, you can do the calculation. But if you're interested to know what is actually going on, all right, this is actually what is going on. First, you start out with a mountain, z equal to fxy, all right? And because you're doing del f del x, okay, means that your y is a constant, okay, meaning that your y is a constant. Right? When your y is a constant, it means y equal to b. Okay? Y equal to b in your single variable calculus is a line. Right? Y equal to b is just a line. Okay? But in this multivariable calculus, it's a plane. Right? Basically, at the value y equal to b, right? In your 2D world back then, you just have a line. Okay? Right? But now, I'm talking about many lines stacked up together. Okay? That means y equal to b. Alright? Y equal to b. But I let it run. Okay? That's why I have a vertical plane now. Okay? That's why I have a vertical plane now. Because it's many lines stacked up and down. Right? Okay? So with this vertical plane of y equal to b, right, it cut the mountain. When it cut the mountain, there will be a curve z equal to f x comma b coming out. 100%. When you cut, okay, it means an intersection. The mountain and the vertical plane of y equal to b, they intersect. Alright? When they intersect, okay, definitely a curve will come out. Okay, and the curve is z equal, the function, okay, if you're interested in the curve expression, is z equal to f x comma b. Because the y is replaced by all the b number already. Okay, so it's the curve is z equal to f x comma b. Is the curve expression for the black color one. And then this part here, our single variable technique come in. You form 2 points that you're interested. You form 2 points. One is the point A that you're interested in. Then A plus H, where it's a slightly off. Okay? And then you, by first principle, you take the limits. Limits of H approach 0. F, A plus H, comma B. Right? Because you fix the B as a constant. You fix the B as a number. Right? So it's A plus H, comma B, minus FAB over H. Alright? This is very similar to what you learned in single variable calculus, and it's the first formula I show you just now, right, for this partial derivative. And this is actually the slope, is measuring the slope of the curve z equal to fx comma b at the point a comma b comma fab, which is basically your del f del x at a comma b. Okay? Very similar to your single variable calculus, but there are more steps involved. But once you get up to here, basically you are looking at a 2D plane already. Okay? You are looking at a 2D plane. Alright? Okay? Don't worry so much. This is more for appreciation and awareness. Okay? Now I have another example where I show you the computation and then I draw the graph for you. Alright, so it should be very clear after this example. Okay, it should be very clear after this example. Okay, now we have this original question. Alright, and then I asking you to find fx 1, 1 and fy 1, 1. Okay? When you find del f, okay, when you find del f del x, alright, okay, you obviously view y as a constant, alright. So from the f function, you find del f del x, you will get negative 2x, right? I hope everybody can see it. You sub in 1, 1, you get negative 2, alright, because 1, 1 is what they are interested in. Right? When you sub in the point, it's always at the very last step. You don't sub in at the first step. You sub in at the first step, then nothing already. right? The f will give you a number. Okay, that is the f function number, the functional number already. All right, so the submit the point always at the last step. Fy, xy, okay, now you differentiate respect to y, keeping x as a constant. Right, so okay, easily you get negative 4y. And you submit 1, 1, you get negative 4. Okay, so you do all these things very beautifully. How do they actually look like? So imagine I draw the z equal to 4 minus x squared minus 2y squared for you. Right? For del f, okay, for del f del sorry, for del f del x, alright, the assumption is that your y is a constant. And because you are asked to analyze 1, 1, where y is equal to 1, so you create a plane, you create a plane at y equal to 1. Okay, this plane cut the mountain, alright, and you have this curve here. Alright, and the curve, right, at 1, 1, which is here, you find the slope. The number that you got up there, negative 2, is the slope. Likewise, for here, okay, for here, okay, you can see that it makes sense, right? It's a negative slope, right? Okay, because you see, you are del f del x. That means you are in relation with the x-axis, right? And your slope is this way. It's not this way, right? It's this way. So it's a negative. Okay? It's a negative. Alright? And over here, right, over here, you have the same thing, right? Now, I'm doing del f del y, means you keep x constant, and in this case, they give you 1, 1, means x equal to 1 constant. You look at x equal to 1 plane, okay? At the x-axis, you find the 1, okay? You create a plane, right? Then you cut, okay? You cut the, okay, basically over here, right? It means that x equal to 1, okay? Your y run freely, your z run freely. Like writing a if loop like that. Alright? That's why you will get a plane. Alright? And then you cut the mountain, okay? You get a curve, right? And then you find the slope at 1, 1. And again, it's negative 4, okay? Because you're now doing del f del y, your y is positive here, right? Your slope is this way, okay? So it's a negative slope. It's a negative answer. Correct. And you can see that this is steeper than this. Okay? It makes sense. Alright? Okay? So the meaning of y equal to 1, okay, in the multivariable world, it means that y equal to 1, okay, your x run freely, your z run freely. That is how the plane come about. Okay? Alright? Okay. Now, naturally, we will have a higher partial derivative, right? Given z equal to fxy, its partial derivative fx, fy are also function of two variables. So we can further take the second order partial derivative as follow. Okay, all this notation, please remember them. Okay, all this notation, please remember them. Okay, so we can write it this way, we can write it this way, or we can write it this way. Okay, all right, or we can write it this way. We can write it this way, or we can write it this way. Right, so take note, this is being done first, okay, this is being done first, then this one. Okay, so over here is fx, then fy. Alright, and over here, you can see that fy is being done first, then you do this. Sorry, the y is being done first, right, then you do this. Alright, so the symbol is fyx. Okay, and we call the fxy and fyx mixed partial derivative. Okay, we call it the mixed partial derivative. Okay, now find the second partial derivative of the following. Okay. Okay. This one, right? I believe that we have done many partial derivative. Alright. So you should be expert by now. Fx, you have this. Fy, you have this. Okay. Please go back and try on your own. Right? Please go back and try on your own. Right? You do a fxx. Okay. Means you take this part here. You differentiate. You partial differentiate it with respect to x again. Okay. Fy here means that you partial differentiate this one with respect to y one more time. Okay? Alright? And I just want to remind you again, when we write it this way, fxy, it means that x is done first, then y. Okay, when we write this way, xy. Okay, we write yx, it means y is done first, then you do x. Okay? So therefore, okay, this one I already mentioned. You partial differentiate the above again. Now, the next one here, okay, you take from the fx here, this expression, you partial differentiate it with respect to y. Okay, then you will get this answer. Alright, and this fyx, y is done first, so you look at this fy. Alright, you partial differentiate it with respect to x, and you get this expression here. Now, the importance of this is actually to tell you that mixed partial derivative fxy is equal to fyx. Okay, so actually flexible. Okay, you don't have to be. You should always choose one that help you conveniently. All right, which I will show you in the. Okay, so just to recap, if fxy and fyx are both continuous, then your fxy equal to fyx. It's independent of the order that you take the partial derivative. So just now I was a bit, keep telling you the which one to take. Actually, that is a good practice. But more importantly, right? Actually, they are the same. You do fxy or do fyx, okay, they will give you the same answer. Okay, this also apply to higher derivative and more than two variable. Okay, all these mixed derivative, okay, give you the same answer. All right. Okay. Okay. Next example. Okay. Next example over here. Find the second partial derivative. All right. That means I want you to do this one first, then this one. All right. Okay, guys. You see the expression that square root thing inside is all x. So if you go and follow my instruction and do x first, you do what? 5 pages too. Okay? So my point here is that you should always convenient yourself. Right? This guy is so ugly looking, right? Remember that fxy equal to fyx. Right? So I deliberately do del f del y first. When I do del f del y, I get 0 plus partial differentiate cosine xy. Okay, and this will give me this, right? And then, okay, after that, I do the partial differentiate respect to x outside. Okay, so this one, of course, is product rule. Right, this one is product rule. Okay, you do product rule and you will get the two terms there. Okay, I will not go through too much. Okay, I leave it to you to practice. Okay, so imagine you have done the other way round. Okay, imagine you have done the other way round. Okay, you have spent like 3 pages. Okay, right? I have a full solution here. You can go and read on your own. Okay? Okay, good. Okay, now we move on to the chain rule. Okay, now we move on to the chain rule. This is the last segment already. Okay, trust me, this is the last segment already. Alright. This is a recap, okay, of what you have done in your high school days, right, for single variable calculus or your earlier days. Alright. Okay, so you have this chain rule for the composite function, y equal to fgt, y equal to fx, x equal to gt. Right? The chain rule is often of the form, let's say you want to find dy dt. Alright? Okay? The way to remember is like this. Okay? You want dy dt, right? You put the dy here, dt here. Then the remaining one, right? Okay, dx, you store it in here and store it in here. Okay? That's what we learned in high school, right? Remember? Okay? df dt, you put the df dt here. The remaining one, you store in dx and dx here. Okay? Sorry, I don't know why I have a value. I put valuable. Okay? It should be all variable. Please go and help me change it. Okay? It's not valuable. It's variable. Okay? But you all are very valuable. You all are very valuable. Okay? Maybe I was thinking of you all. Okay, anyway. Okay? This is the diagram of the visualization. Okay? Right? Okay, so we have one example here based on your single variable calculus. If your y equal to cosine t squared plus 1, okay, we can decompose it as y equal to cosine x and x equal to t squared plus 1. Alright? And then we find dy dt. dy dt, we write it as dy and dt, split it like that, and then dx dx. Okay, then we go and find dy dx, we have this expression. We go and find dx dt, we have this expression. Okay, then we multiply together. Always leave it to the most simplified version. Alright? Okay, now we are directly going to extend it to, okay, the multivariable calculus way. Right? So now, I want to tell you that you are in multivariable calculus world. This is the most basic and easiest. Okay, one independent and two intermediate. Okay, one independent and two intermediate. What do I mean by that? Okay, consider your w equal to fxy, x equal to xt, and y equal to yt. Right? So I give you a function above as an illustration. W equal to sine squared x plus y. Okay, your x is cosine t, your y is sine t. Right? So the intermediate variable is your x and y. The independent is your t. Right? Independent. Because t is like the time. Right? Based on whatever time, then you sub it in, you get your x, you sub it in, you get your y value, then you submit the x value and y value back into your fxy there. Right? So your x, y are intermediate. Your independent variable is t. I need you to remember this diagram. Okay? So you start out with w. Wow, I write until so can you see or not? Sorry. Okay. I think here. Okay. Yeah, here. Okay, I zoom in. Okay, I zoom in for you. Alright. So you can see here. You start out with the W. Okay. You start out with the W. Right? And the T. Okay, the T is the independent variable. Depending on how many independent variable you have, then you will draw this. Let's say you have two independent, you have to draw two of this. Okay, you have three independent of this, you need to draw three of this. This question only one independent, so it's W to T. Intermediate is your X, Y. Okay, you move it, you move it, you move it, you move it. So your W, you move to X, del W, del X. From X, you move to T, del X, del T. Like that is multiply, multiply. Okay, over here the same thing, del W, del Y, right? When you move from W to Y, del W, del Y. From Y to T, dy dt. Alright? Okay? So you move is multiply. Then you sum them up. Now, there's a few things I want you to take note. Okay? Even I myself just now said wrongly. Okay? This is dw dt, right, is del w del x. dx dt plus del w del y dy dt. So you must be sure you are looking at single variable or multivariable. Because this is single variable one. So your dx dt is the normal d. Alright? But you're dealing with w, you're dealing with multivariable. So it's del w, del x, del w, del y. Okay? Alright, and then you sum them up. Okay? Let's come back to here. Okay? Remember, you follow the path, and then you sum them up, you get this. Okay? Let's move on. Now, one intermediate, Now we move on to one independent, three intermediate. Alright? So the example is given there. W is equal to f x, y, z. Okay? X equal to xt, y equal to yt, z equal to zt. Alright? So, now, because of one independent only, so there's only one diagram. Okay? There's only one diagram. Alright? So you start off with the W, f, x, y, z. Alright? The last one is t, independent variable. Okay? But your intermediate is now x, y, z. So you have x, y, z. And then you have to move the arrow. Del w, you move here, del w, del x, dx, dt. Del w, del y, dy, dt. Del w, del z, dz, dt. Alright, and you move it down, it's multiplication. You move it down, multiplication. You move it down, multiplication, add up. Because partial derivative, you need to add up everybody effect. Alright, okay? So you add up, because it's partial. So you add up everybody effect. Alright? One independent, three intermediate. Wow, so many formula. But okay lah, not too difficult. Okay, so I write everything nicely for you here lah. I wrote everything nicely for you here already. Okay, you can refer. Okay, now let's take a look at one example. Okay, I have a z equal to x squared y plus 3x y4, x equal to sine 2t, y equal to cosine t. Alright, so straight away, okay, you must draw the diagram first. Right, you must draw the diagram first. So in this case, it's clear cut lah, Okay, your diagram is z to t, intermediate x, y. Okay, then you follow the path. Alright, okay, you follow the path, you will get dz dt is equal to, okay, you follow the path, you get the formula in the square box, in the rectangular box. Okay. Alright. Okay, then now you go and work out every term. Del z, del x, you go and find out on your own. Del z, del y, you go and find out on your own. Okay, partial derivative, I leave it to you to go back and try. I cannot be doing all the partial derivative question for you in the class. Okay, so you sub in the del z, del x times the dx, dt. Okay, simple. I leave it to you. Alright, and then it's a positive, but it's a negative there because of the dy dt, right? Dy dt, your dy dt give you negative sine t, right? Okay, that's why I have a negative here, and the sine t, right? They are linked together. Okay, and then the del z, del y, okay, you do it del z, del y. Alright? Okay, for this case, it's not necessary to substitute the expression of xy in t. Instead, okay, Because the question is asking for at t equal to 0. Okay, at t equal to 0. Okay, so at t equal to 0, okay, your x0 is 0. Your y0 is 1. Okay, so now you have all this value already. Okay, you sub it in, okay, accordingly at your dz dt, evaluate at t equal to 0. You sub in all the corresponding numbers and you will get an answer. Okay, I have provided the full solution. All right, so you can read it on your own. Okay, now we move on to 2 independent, 2 intermediate. All right, 2 independent means that you need to have 2 diagrams already. Okay, there will be 2 set of answers. All right, so for W equal to Fxy with x equal to GRS and y equal to HRS, right? So I have a R and a S diagram. Okay, so this is W. Okay, the intermediate is XY until R. From here is W, XY until S. Alright, okay, then you do exactly what I have been teaching you, right? You will get you need to show me 2 answers. Okay, the first answer is from here, del W, del R. Okay, you have this expression here, okay, based on the first diagram. And then you have the second, okay, answer, del W, del S, okay, you form from here. Okay, you form from here, plus you form from here. Okay, the second term. Okay, so you need to give me 2 answers. Alright, if there are 2 independent. Okay, it's because of these 2 independent. So there's 2 diagram, and that's why there's 2 set of answers. Alright, so in the quiz or exam, I can change it. I teach 2 independent, but I can put 3 independent, 4 independent, 5 independent. You can still have the methodology to work out. Alright? I cannot be going through until 5 independent and show you. Alright? Okay, but I show you another case here. Okay? 2 independent and 3 intermediate. If W equal to Fxyz, okay, with x equal to GRS, y equal to HRS, and KRS, alright, find the expression. Okay, so maybe I use the clean slide here in case you all cannot see. Okay, so because it's 2 independent, alright, because it's 2 independent, okay, there's supposed to be 2 graphs lah. Okay, there's supposed to be 2 graphs, and there will be 2 sets of answers that you need to give me. Alright, so let's go through one diagram can already. Okay, so it's W to R, right? Because here is RS, right? So W to R. Your intermediate is 3 intermediate XYZ. So XYZ. So you do this way, this way, this way, this way, this way, this way. Add them up, add them up. Okay, that's why you have this one plus this one plus this one by following the diagram. Okay, you can also do the same thing. So this will be from W all the way traveling to this one will be S. Okay, you can also do the same thing. Okay, so this will be from W to S. Okay, and then this will give you the second answer. Alright, okay? Alright, okay, so just know how to draw a diagram can already. Because in an exam, you can draw a diagram, you follow the path. Then you multiply out and then sum them up, all the effects from each. Okay? Okay, we do one example. Alright, we do one example. Find WR and WS if they give you the W is there, X is there, Y is there, Z is there. Wow, so many things. Okay. Anyway, right? So, okay, so for this case, I draw the diagram for you. W, right, and R, right? Because, yeah, W and R, right? So you just need to do this X, Y, Z. And then from here, you go to here, here you go to here, here you go to here, right? Yeah, correct. And then you need to draw another one is W, and then X, Y, Z. Do like this, and then now you go to S. Okay, you need to draw two diagrams. Okay, you need to draw two diagrams. Okay, so for the first diagram, okay, for the first diagram, okay, first diagram you can see W go to X, then go to R. W go to Y, then go to R. W go to Z, then go to R. Okay, I've already written the full solution here anyway. Here. Okay, if you follow my graph, okay, if you follow my chart there, number 1, okay, you will get this formula. Alright, and then I leave it to you, okay, I leave it to you to sub in to do the partial derivative for every term. Then you do your multiplication and sum it up. Okay, I leave it to you. Go back and try. Make sure you go back and try. Okay, and from the second diagram, okay, I hope it's correct. Let me just double check again. Yes, it's correct. Okay, so from the second diagram, right? Okay, you follow the directions. Okay, you will now be able to get this. Alright, you will now be able to get this. Okay, this is from the second diagram. Okay, okay, and then you sub in the individual term, right? You simplify and you will get this answer. Okay, I will not say too much. Okay, there's a last question. There's a last question. Alright, there's a last question here. Alright, I believe we have time to do. Alright, okay, so sorry about that. Okay, those who need to leave, you make a move first. Okay, I will just finish up this question. Alright, and then I will call it a day. I promise you. Alright, okay, but I think I've done a good job already. Last year I took 2.5 hours to teach this. Sorry about that, guys. Watch the video, guys. Okay, so let me just go through this. This is a PDE, alright, partial differential equations, right? Because the bottom here is different, okay, right? It's del R and del S, right? So it's not the same. It's not X or Y, all right? So this is what we call the partial differential equation, all right? So W equal to F X comma Y, X equal to R squared minus S squared, okay, and you let Y equal to S squared minus R squared. Okay, I need to write it like that so that it's in line with the formula that we have already, encountered. Then we can use back similar idea and methodology. Alright, okay, so this is the first step you need to do. And after you have done that, okay, you know that your W, okay, you have X and Y, and then you go to R, okay, and then you have also W, your X and Y, okay, and then you go to S, okay, these are your two independent variable, okay. So from the first diagram, okay, my del W, del R, give me del W, del X times del X, del R plus del W, del Y times del Y, del R. Okay? Okay, whatever I can simplify, I simplify. Okay, so this del W, del X, I can rewrite it as del F, del X times del X, del R, that means it's 2R, right? Plus del F, del Y okay, del y del r, del y del r, negative 2r. Okay, right? And then the next one, del w del s, okay, I look at the second figure, right? I will get del w del x del s plus del w del y del s. Wow. You all must also read and help me verify, okay? Right? Del W, del S, okay? You follow the lines, right? So you follow the lines, del W, del X, del S, del W, del Y, del S. Okay. So once you confirm the formula is correct, you go and sub in the, okay, so you have del F, del X minus 2S plus del F, del Y times 2S. Okay? Alright? Now, the question tell you S of del W del R plus R del W del S. That means the S of this whole thing above plus R of this whole thing above, you go and multiply out. Okay? You will see that they all cancel off beautifully. Okay? So we have already proven the expression above. So this is a very quick and dirty way to solving PDE. Right? If your PDE is of this form, right, that means the solution, right, is the F. Okay? Solving this kind of PDE, right, you can use the solution F in that form above. Okay, guys, thank you so much. Okay, I'm very happy, right, to finish this set of notes. Right, I'm very happy, okay, to finish this set of notes. Okay, yes, all right. So thank you for your time. Okay, that's all for today. All right, thank you for your time. Okay, thanks a lot.
Reason why you change CW to